One line goes through 6, 7, and 0, -1. The other line is pictured. Are they parallel? Parallel means they share the same slope. So this slope right here looks like it's put a dot there, put a dot there, up 1, 2, 3, over 1, 2, 3, 4. So that slope looks like it's -3 over 4. And the other slope, let me close a few tabs.
I think I closed the wrong tab. How did that go, Mr. Perich?
I'm sorry. I was trying to close tabs, and I accidentally closed the most important one.
Put that in the video.
Huh?
Put it in the video.
I think it was still recording, so I'll keep it in the video. Don't worry. All right, let me get it back. So much for me wanting to get things done and done fast. All right. Let's try this again. I'm going to close a few tabs. Okay. All right. That was a close one. All right. Boom. All right. So anyway, the line that's going to pop up, add explosions. I'll try to remember that. This line right here has a slope of -3 and a 4. -3 over 4. I need to find the slope of this John and see if this slope and that slope are the same thing. So I'm going to label you x sub 1, y sub 1, x sub 2, y sub 2. The slope of a line, if given 2 points, is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is -1. Minus, always put a minus in the middle, which is funny because I've heard of monkey in the middle, but minus in the middle, that's different. That's supposed to say 7 parentheses. The lag is still there. 0 minus, always put the minus in the middle, which is funny. So by doing this, I get -1 minus 7, which is -8 over -6. Which is a double negative. So I was way off on this one, 4 over 3. So are they parallel? No, but you know what they are. You know what they are. You know what they are. And I didn't mean for this to happen, but oh, sometimes the good Lord smiles down on us. They're negative reciprocals. Because this one is that one flipped and negative, which means they're actually perpendicular. That is good. Today he is. And always. And always. Oh, oh yes. Well, okay. I'm sure the majority of the boys in this class have used this meme to describe themselves. And that's okay. Someday you'll find love. It may be in the arms of your mother or somebody that you order from a different country. It doesn't really matter. Doesn't really matter. This is different than what we did last time, where instead of being given parallel lines and finding some perpendicular information, I'm sorry, not perpendicular. Instead of being given parallel and we're trying to prove that angles are congruent or whatever, oh boy, I really offended Keon. We're given parallel or lines like that are equal to each other, angles that are equal to each other, and we have to find that they're parallel. So everything that we do today is the reverse, or as we in Mathland used to say, or like to say, the converse. Hey, now you're an all-star. Because Converse is the type of shoe called all-stars. Chuck Taylor's. So the converse of corresponding angles postulate says, like, look, if you have corresponding angles that are congruent, like that one and that one, if they are congruent, then the lines are parallel. That's called the corresponding, or the angles. Oh my gosh, the converse of the corresponding angles postulate. Okay. Before, we were told if they're parallel, then corresponding angles are congruent. Now we're told if corresponding angles are congruent, then these guys are parallel. It's the converse. It's the backwards. Okay. I like to call this the converse of cap. And I know some of you are like, no, Mr. Perich, no cap. I'm telling you right now, cap. Parallel postulate. If given a line and a point not on the line, there exists exactly one line through the point that is parallel to the given line, something that we will probably never use. This is what the opposite, the converses of what we learned last time. If we have, what we learned last time would be the alternate exterior angles theorem, where the alternate exterior angles theorem says, if I give you parallel lines, then alternate exterior angles are congruent. Now I'm telling you that if they're congruent, then the lines are parallel. Same thing with interior angles, same thing with alternate interior angles, and same thing with perpendiculars. Okay. So let's get to it. And we're probably going to refer back to these things a lot. Again, the regular ones that we're used to from the other day are, if these lines are parallel, then these angles are congruent. Now the converse says is, if these angles are congruent, that means the lines are parallel. And we're going to use these guys along with the corresponding one quite a bit. So when we called them the alternate interior angles theorem, now we can call it the alternate interior angles converse, which is the same thing, but backwards. Let's do a little bit of math, because why not? Given the following information, determine which lines, if any, are parallel. All right, so state that the postulate or a theorem that justifies your answer. If one is congruent to 3, then we could say that J and K are parallel because of the corresponding angles, the converse of the corresponding angles. Did I say that right? The converse of the corresponding angles postulate, or we could call it corresponding angles converse. Yes, thank you. JK. Just kidding. Cap, yes. Camilla, yes. Yes. Oh. Let's see if this one is the cap, or maybe it's the no cap. Oh, no, I can't believe it. 2 is congruent to 5. If 2 is congruent to 5, we have alternate exterior angles. And so the converse of the alternate exterior angles converse would show that J is parallel to K. So without having to do 3 and 4, this is mostly just saying, oh, look, those are alternate interior angles, or those are corresponding, or alternate exterior angles, and that's good. We could do these, but again, time is money. We won't worry about these. Find X so that M is parallel to N. These guys are going to be alternate exterior angles. Alternate exterior angles. And if those are equal, then these will be parallel. So find X so that M is parallel to N. Well, if they're going to have to be equal in order for it to be parallel. So let's set that equal to each other. And this is using the theorem, the alternate exterior angles converse. Again, I'm a math guy, and most of you kids are math kids, and you came into this class like, oh, great, we're going to learn about shapes and stuff. And no, we're not. We're not really learning about shapes. We're learning about proofs, at least for now. So you're probably mad, TBH. You're probably mad, wondering why we're not doing so math. Well, here's a little bit of math. And, we are using the alternate exterior angles converse to do it. If you were to, in a proof, say this is the converse of the alternate exterior angles theorem, or this is the converse of the alternate exterior angles postulate, that's fine. That's fine. But I said it like several times, so we're not going to do it. I printed out the proofs, so why don't you quick figure out what X is and BRB. BRB. I'm back. Guess who's back? Back again. Mr. Perich is back. Tell your friend. Guess who's back? Guess who's back? Guess who's back? Got my proof. Guess who's back? It is me. Guess who's back? Blah, la, la, minus 2x from both sides. My name is Mr. Perich, and I'm here to say that I'm going to rap some rhymes in a fun mathy way, and I'm not really good at this, and I can't rhyme off the top of my head, but that's okay. As you kids would say, I'm dead. See, actually, I'm not that bad. I use popular phrases that you kids are super into. I was able to do math at the same time. This is math we all know. I think Athena, was it Athena who put the answer up there? Good gravy. Thank you, Athena. Athena, right. Athena, right. Oh, it was also Lily. Apologies. Oh, I said Athena, right. And she said, that's not my last name. Oh, boy. We are fun. We are fun. I think I'm going to pass on the video. I don't need the extra view. And I think I'm going to pass on the fill in the blank proof as well. Now, let's quick do it. I'm told that angle 1 and angle 2 are congruent to each other. Okay. I'm told that angle 1 and angle 2 are congruent to each other. That's the given. This person says that 2 and 3 are congruent to each other also. What are 2 and 3 in relationship to each other? So I can say definition of blah angles. Start with a V. Good job. I'm out of room, so I'm going to use the angle system symbol. I can't talk today for the word angle. If angle 1 is equal to angle 2, as stated here, and angle 2 is congruent, to angle 3, then 1 is congruent to angle 3. And if 1 is congruent to angle 3, then we could say that L is parallel to M. And if they decide to use 1 and 3, then that's the converse cap. That's the converse of corresponding angles postulate. Now, no cap. I would look at this, and this would be a two-stepper. And here's why that I would have this be a two-stepper. If 1 is congruent to 2, those are alternate exterior angles that are equal to each other. And according to the converse of the alternate exterior angle postulate, which is right here, if two lines in a plane are cut by a transversal so that a pair of alternate exterior angles are congruent, then the two lines are parallel. So if I was told that 1 and 3 are congruent, then P is parallel to Q. So why all this fluff in the middle? I don't know. But I'm going to tell you what, if we are given the opportunity to avoid the fluff, I'm going to avoid it. I'm going to avoid it like the plague. And so, oh, I shouldn't have said plague in the middle of a pandemic. I am so sorry. Oh, guys. Oh, boy, that was awkward. Oh, boy. Oh, no, why did I say that? Oh, this is so embarrassing. So this could have been a two-stepper. And we've been doing that a lot lately. We've been doing quite a few two-step proofs because now we're learning all this new information. We don't necessarily need to do like 1,000 different things. So the next thing on this thing is a proof. So let me get my camera ready. Is this the rest of what we're doing? Proof. Yeah, so let me stop presenting so it's easier for you to see the proof, so you can blow it up a little bit more. Also, when I turn it into a video, I don't have to make it all like awkwardly zoomed in like I did with the last video. All right. I think that's pretty crisp. Cocoa Crisp. Cocoa Krispies. Given angle 1 is congruent to angle 3, and that AC is congruent to BD, prove that AB is congruent to CD. Again, I go into these proofs not looking at them ahead of time. I don't. Although this one does look familiar. I might have made a video about this one weeks ago. So I don't know. It does look familiar though. When I see these, I like to extend the lines out a little bit more so it helps me see it. Although it's not necessary, it just helps me in my difficulty to focus and stuff like that. It just helps me out. What am I told? I am told that 1 and 3 are congruent. I'm also told that AC, which is this guy, and BD, which is this guy. And you know what? I forgot one line. I'm also told that those guys are congruent. So I have to, or I'm sorry, parallel. Or no, yeah, parallel. So these guys are parallel. And if these guys are parallel, boom, boom, and 1 and 3 are the same, I'm first going to start out by saying this. Okay, so step 1, obviously. Step 2, I'm going to pretend that this line doesn't exist right now. So let me take this piece of paper. That line doesn't exist. Okay, I have 3 numbers here. So I have to find a way to connect 1 and 3 to 2. How am I going to do that? Well, since my eyes are awful at seeing visual stuff with math, I'm going to take away that line. So now what I see is can I take away that line? No, I can't yet. All right, so I can't take away that one. I have to take away this one. Oh, that's obnoxious. Sorry, not the end of the world. So I really can't use 2 here. I mean, I could, but I won't. This is what I am going to say. I'm going to say that since these 2 guys are parallel, since these 2 guys are the parallel ones, this guy and this guy right here that doesn't have a name are going to be congruent. Okay, so angle 1 is going to be congruent to, I'll call it ABD. Angle 1 is congruent to angle ABD, and that's because these guys are corresponding angles. So that's the corresponding angles postulate. Also, if these guys are congruent. Oh, okay. Since one is congruent to 3, I can say that angle 3 then is also congruent to angle ABD. And that's using substitution from my given. So if these two guys now are the same, these are the alternate interior angles of lines AB and CD. So if the alternate interior angles are congruent, then that angle or line AB is parallel to line CD. Oh, I'm sorry. I'm so sorry. You're absolutely right. I didn't realize that I was completely out of the way. Angle 2, or problem 2, is I said that since these two guys are parallel, then these guys are going to be congruent to each other. So angle 1 and angle ABD. Now, if angle 1 is equal to ABD, and angle 1 and angle 3 are the same thing, then angle 3 is going to be ABD, and that's substitution. Or I guess I could have used transitive property. Maybe I'll turn that into transitive property when I get there. Now, since these two guys are equal to each other, and they're the alternate interior angles of this line AB and that line CD, I can say that AB is parallel to CD using the converse of the alternate interior angles theorem. Or they like to call it the alternate interior angles converse. So we'll call it that. Which is fine. It's all good, as Jim Halpert once said when he was the co-manager of Dunder Mifflin. There we go. Statements. Reasons. Statement number 1, always the given. Angle 1 is congruent to angle 3. Also, AC. Oh my gosh, is parallel to BD. You can tell I didn't get a ton of sleep last night. Having babies. You just will never sleep again. It's my given. 2 is I said that since these are parallel, angle 1 is equal to that angle right there, and that angle is called ABD. So 2 is angle 1 is congruent to angle ABD, and I used the corresponding angles postulate. Something we learned the other day. Since 1 is 3 and 1 is also ABD, the substitution or transitive property says that, well, 3 is equal to ABD, congruent. And I like using the transitive property because it just sounds nicer. It sounds more professional. And if angle 3 is congruent to angle ABD, that finishes our proof. And that's the alternate for the alternate interior angles converse. So not pretty. And unfortunately, this next one is going to kind of follow suit on the not pretty train. Very similar. We're given some weird shape. We're given information about angles. And we have to somehow find a way to turn that into two lines being parallel, which means we need to figure out corresponding angles or alternate interior angles or alternate exterior angles, yada, 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 yada. ABC, this guy, is congruent to ADC, that guy. I have to prove that AB, this guy, is parallel to CD. And this guy would be like my transversal. At least that's what I think I'm going to use. All right, so let's see what we can do. Let's see what we can do. There's my given. Also, I have this information that stuff equals 180. Hopefully, that will help me out in some way, shape, or form. We shall see. We shall see. Angle A, I mean, it will help us out. Angle A is plus ABC is 180. So what that tells us is these two are corresponding angles. I'm sorry, consecutive interior angles, okay, of AD and BC. So that's my step one. Step two, I can say that AD and BC are parallel. And so that can happen now, and that can happen now. And that's the consecutive interior angles converse. Ooh, CIA. What are we doing? Spying on people up in here? Sorry, Santiago. So, looks like by doing what we just did, I was able to, like, my red line and my blue line here are the same line. So I should at some point to be able to connect these two. And if I can connect these two, I'm done. So I can say that since A, oh, did I even, okay, look at this information right here. Look at this, look at that, look at this, look at that. Since ABC and ADC, or is ADC, and ABC is also used here, I can say that the measure of angle A plus, I'm going to replace that ABC with ADC. And that's substitution, or I can use transitive property again. Now look at these two. So I just said that this guy right here and this guy add up to 180 degrees. These guys also are consecutive interior angles of U and U. So A, B, and C, D are parallel. And that's also the consecutive interior angles converse. And fun fact, I don't need this. Doesn't help us. It's not what I'm trying to prove. Not necessary. I was able to take this given right here And since ABC is equal to ADC, I can just replace that ABC with that ADB. It's no big deal. So here's my proof. Statement number one, always the given. Two is now the old three. Since ABC and ABC are seen in both, I can just turn that ADC here. So I said the measure of angle A plus the measure of angle ADC is 180. And that's the substitution or transitive property. It's all good. And so since these two guys are the same, that would make these guys parallel to each other, which is what I'm trying to do. So AB is parallel to CD, and that's the consecutive interior angles converse. There's a kitty cat rapping at my window. Hello. Hi, Zero. What a gorgeous creature. So that's gonna do it for today. RRNS parallel. Well, let me see. Are these 64? Yep. And is that 64? Yep. Then the answer is yep. 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 Let's draw it in a nice cursive. And that's again because this John adds up to 64. And so according to the corresponding angles postulate, converse theorem,